Hey everyone, today we're going to learn about weight and mass. Most people think that weight and mass are the exact same thing, but they're not. And in physics, it's going to be really important that we know the difference. So today's essential question is, what's the difference between weight and mass? Let's start with mass. Mass is the amount of matter in an object, or the amount of stuff in an object. And weight, on the other hand, weight has to do with mass, but more importantly, it's a force. And this force is the force of gravity. So it's the gravitational pull on an object. So mass is the amount of matter or stuff in an object, and weight is the gravitational pull on that mass. Another difference is that mass is independent of location in the universe. Whereas weight is dependent on location. So let me give you an example to help conceptualize this idea of independent and dependence on location. So let's pretend that you're an astronaut, and here on Earth, you have a mass of 60 kilograms. And if you were to take a spaceship and then go to the moon, the amount of matter in your body does not change. So that means the amount of mass does not change. You would still have a mass of 60 kilograms. And this is true if you went to any planet or anywhere in the universe. If your mass is, if you don't, the amount of matter or stuff in your body doesn't change, your mass does not change. But the force of gravity on your body or your weight does change. Okay? And there's actually an equation to calculate your weight. And that is F of g, the force of gravity or weight, is equal to your mass times the acceleration due to gravity, little g. And we learned that little g, the magnitude is 9.8 or 10 meters per second squared. And that acceleration due to gravity is only true if we remain on the surface of the Earth. That acceleration remains constant at minus 10 meters per second squared. But as we get further away from the surface of the Earth, that force of gravity actually decreases. And so that acceleration is going to decrease as well. Since that acceleration is decreasing, then the force of gravity is weaker and weaker and weaker. And that's because the force of gravity is actually a field force. So this gravitational field decreases the farther we get away. So if that mass is here on Earth, if you're on the surface of the Earth, you're going to have the strongest force of gravity. But the farther you get away, that force of gravity decreases. Okay? And so let's calculate your weight here on Earth, and let's pretend that your mass is 60 kilograms. So if the force of gravity is, or weight is mass, is 60 kilograms times 10 meters per second squared, then your weight is going to equal 600 newtons. On the moon, your acceleration due to gravity, or the acceleration due to gravity on the surface of the moon, is actually 16.5%, or about 1/6 the acceleration on Earth, which means the force of gravity is 1/6 that on Earth. So if we know our weight here on Earth, we can just divide it by 6. And so 600 divided by 6, our weight is going to be 100 newtons. So significantly less. And so what that means is, let's say you brought a bathroom scale with you to the moon. And you stepped on it here on Earth. When you step on it, well, gravity is pulling your mass down right here onto that scale. And so this scale would read 600 newtons. If you brought it with you to the moon and you stepped on it there, it would read 100 newtons. All right. A couple more things to add, little housekeeping items, is that mass, and we already kind of wrote it over here, but the base SI unit for mass it's measured in kilograms, or kg. And they're just a reminder that the prefix kilo is 1,000. So 1 kilogram would mean it's 1,000 grams. And we know that weight is a force, so it is measured in newtons. And lastly, weight is a vector because we know gravity always pulls down. So down is a direction. And mass has no direction associated with it. And if you recall, we call these types of quantities scalars. All right, to just summarize everything again, is that mass is the amount of matter that's in an object. It is independent of location, meaning if you were to stand here on Earth and you have a certain amount of mass, that mass does not change if you move anywhere in the universe because the amount of matter in your body doesn't change as well. It's measured in kilograms, and mass is also a scalar. And weight is, remember, it's the gravitational pull on an object. It's the force of gravity. It's the effect of gravity on your body. And it is dependent on location. So if you were to move from Earth to any other planet or the moon, your force of gravity or the force of gravity on your body would change as well. And we can measure, or we can calculate your weight by taking your mass and multiplying it by the acceleration due to gravity. Since weight is a force, it is measured in newtons, and force is also a vector, which means it always has direction, and weight is always going to pull straight down towards the center of the Earth. So I think that's it for today, and I hope you have a solid understanding of the differences between weight and mass. So if you could, help me out, like this video if you like what you see, and hit that subscribe button right down there. All right, take it easy, everyone. See ya.